Hello, everyone. This video is going to be about the Earth Layers Research Part 3. In case you did not get these during class, didn't get the answers from somebody else, then you can use this to get the answers in order to do the project, or if you haven't done the assignment, you can fill in all those answers and get those turned in as quickly as possible to get some points. I'm going to go through this pretty quickly because since it's on YouTube, you can just pause it, run it back, whatever. So share my screen here. All right, so the first question on part 3, which layer is the thickest? Mantle. Which layer is the thinnest? Crust. Which layer is the warmest? The inner core is the warmest. Which layer is the coldest? The crust. Why are the layers of the Earth in the order they are? So the most dense materials sank to the center when the Earth was melted. So when everything was molten, everything was melted, that most dense materials sank to the very center. So that's why most of the metal in Earth is at the very center. How do earthquakes help show the inside of the Earth? They kind of act like X-rays. So X-rays let you see the inside something that you can't actually see into. Seismic waves kind of do the same thing because scientists know how those seismic waves behave in certain materials, how quickly they move, that sort of thing. So they can use that information to determine what's underground based upon that. Why is the inside of the Earth hot? So a lot of the heat is left over from formation, from when the Earth itself formed, and also radioactive decay, because there are radioactive elements that are giving off radiation, and that keeps the Earth warm as well, or the interior of the Earth warm. The two most abundant elements in the crust, oxygen and silicon, and if you add those two up, 74.3%. If you had your own numbers, hopefully they're close to these. They don't have to be exact, but if you do need the numbers, you can use these for the 8 most common elements. Deepest mine in the world, this Penning gold mine in South Africa, and it's about 4 kilometers deep, and then the deepest that humans have dug is this Kola super deep borehole in Russia, and 12,262 meters, so over 7.5 miles deep. With the crust, I didn't really put averages on here. Continental crust is much thicker than oceanic crust, so like I said, you don't really have to put averages on there. You can put something down. The continental is much thicker than oceanic crust. Also, with the densities, so continental crust about 2.7 grams per cubic centimeter, oceanic about 3 grams per cubic centimeter. Note that oceanic crust is more dense than continental crust, and the mantle rocks are more dense than both of the different types of crust. As far as the ages, continental crust is about 4 billion years old, and oceanic crust is about 260 million years old. But some oceanic crust is much, much younger, which we'll talk about later on. And then most continental crust is granitic, or has granitic composition. That just means that it's made up of a certain set of minerals, whereas oceanic crust is primarily basaltic composition, so it's kind of made up of a different set of minerals, which those different minerals make it more dense. How does the mantle move, and which moves the crust? Convection currents, that's the main thing. Hot material rises as it heats. It hits the crust, it can't keep going, so it spreads out. It cools down, so then it sinks. It gets heated up and it rises, so you get these convection currents forming. And that actually slowly pulls apart the plates, just kind of like in that drawing. The relationship between the outer core and the Earth's magnetic field, because the outer core is liquid metal moving around a core of solid metal, it generates the magnetic field. So the Earth's outer core generates the magnetic field. How do scientists estimate the temperature of the core? The melting point of iron is something that we know because we work with iron here on the surface. We build things with it, we manipulate it. So since we know the melting point of iron, we know that even though it's underground, the outer core has to be at least that temperature. It's going to be above it because it's melted. So we know that it has to be at least that temperature. And how's the core change? Over the past 4.6 billion years, it's slowly cooling. It's just like if you cook something in the oven, you take it out and put it on the counter, it's going to cool down eventually. Well, the Earth is the same way. True, we have radioactive elements that are giving off radiation that keep the interior warm, but it's still cooling over time because those radioactive elements are there's less and less of that all the time as well. And then what will happen in the future, or what will happen to the Earth's core in the future? Eventually it will become cool enough to where it will freeze. So since freezing is just matter going from liquid to solid, that metal will go from liquid metal to solid metal. When that happens, then we don't have a magnetic field. And when we don't have a magnetic field, then we don't have protection from the vast, vast, vast majority of the sun's radiation. And so that will be pretty much the end of everything on the surface of the Earth. So I hope this helps. And like I said, I know it's quick, but you can pause it, run it back, whatever. So take care.